My goal in this lecture, lecture 3, what is cognition, is to answer that question for you. What is cognition? What is it all about? So what's gonna be helpful for you if you're using the Genius of Dogs is if you check out chapter 1 and 2, there's a discussion of that. And if you are interested in using Dognition, there's obviously discussions about what cognition is there as well. But instead of me trying to define what cognition is, why don't I just show you what it is? So this is Yo-Yo. Yo-Yo is a young chimpanzee on Ngamba Island, and she's faced with a problem she's never seen before. At the bottom of that PVC pipe attached to the room that she's in, there are 3 peanuts. Now, peanuts for a young juvenile female chimpanzee is a big deal. Imagine something you really, really badly want, a nice car, a raise, your diploma. It's like those peanuts. So she would like to get them out of the tube. But the problem is the tube is fastened to the bars. She doesn't have any tools available to her, like a stick or a rock. She can't break the tube. She can't remove it. What is she going to do? Well, my challenge for you is to see if you can solve that problem as fast as Yo-Yo does. Obviously, we have everything in there that you need to have an animal happy in captivity. She is able to solve this problem in the room, even though there are no tools and nothing available to her that she normally would use to solve a problem like this, almost immediately. So my question to you is, you faced with the same problem that you've never seen, just like Yo-Yo hadn't seen it. Can you solve it as quickly as she can? Okay, so here we go. See what you can do. All right, she's got the solution. What about you? Does everybody know what it is? Wow, we were as amazed as you are. Yo-Yo went to the water fountain in her room and she filled her mouth with water and she spit it into the tube because she had to infer that peanuts float. She had never had this game, she'd never played this game before, but she was able to put 2 and 2 together, which is she knows peanuts float, she's got water right there. What if she fills the tube up with water and she can get her peanuts? She's almost got them now. The interesting thing and the funny story is that we didn't just test Yo-Yo, we tested a whole group of chimpanzees, and there was a very male strategy. So if you're one of those people who's saying, I knew that that's what she was going to do you know the second solution? And of course, what many of the male chimpanzees did is they actually peed in the tube, and the peanuts floated up. So there are tremendous, what cognition allows for is tremendous flexibility. And this is an example of chimpanzees using inference, or the ability to really do mental trial and error, to imagine the solution to a problem before you ever have experienced it, and use some previous ability or some previous understanding of the world in a completely new context to flexibly solve. There's no learning involved here. It's really, I understand how the world works, and therefore I can use that understanding to solve a completely novel problem. Now that is cognition. But what about other animals? Is it just animals closely related to us that are capable of inferential reasoning? Well, that's been the big surprise over the last 10 years as people have gotten excited about studying dogs. No, it ends up that there are dogs who clearly are using inferential reasoning to solve very challenging problems. We're going to talk about Rico and we're going to talk about Chaser later in a later lecture, but what we learned from Rico and Chaser and subsequent research is dogs are also using inference to solve a variety of problems where they're not just simply always learning over lots of practice and repetition. They can really infer the solution to a problem, and many times a problem they've never seen before. So that's cognition. Okay, but cognition isn't just inferential reasoning. It's also more than that. It's a way of viewing intelligence. So I think the old way, or the traditional way that people view intelligence, is it's something you either have more or less of. It's like a cup that's half full or half empty. And a cognitive approach is very different than that. A cognitive approach looks at intelligence as something that is not unidimensional. There's not just one type of intelligence. In fact, there are many, many types of intelligence, and we're not even sure how many there are and which types of intelligence different species show. So when you take a cognitive approach and you see that there are things like navigation, memory, social learning, inhibitory control, and many other things, what you start to realize is that thinking about more and less cognition doesn't make sense, because many of these different kinds of cognitive abilities, they vary independently. What that means is just because you have a lot of inhibitory control, it doesn't mean that you're an amazing social learner. So take these bubbles and the size of the circles as an indication of how much of an ability there is. And just because you have a lot of inhibitory control, it doesn't mean you have a lot of social learning, and it may not have anything to do with your memory or your ability to navigate. That is a very different way to view the world than there's just one thing and you either have a lot of it or less of it. So here's another potential cognitive profile that could come out from taking a cognitive approach. You have another individual that has amazing social learning skills, inhibitory control, not so much. So who has more intelligence? The one that's really amazing at social learning, or the one that has a lot of inhibitory control? So the challenge is no longer determining whether or not a species or an individual is smart or not, but rather it's to understand the cognitive profile of an individual or species. And how is it that those profiles developed, evolved? And in the case of dogs, how do we use that information to either better teach them or to have a stronger relationship with them? So here's an example of taking a cognitive approach. It's no longer that one animal has more or less intelligence. There's lots of different types of intelligence, and different individuals or different species have different cognitive profiles. So one profile is represented on the top, where you have one individual or one species who has a lot of empathy. And the species below, well, again, has a lot of inhibitory control, but not so much empathy. So who's smarter? It's actually at this point really hard to say. It's much more interesting to think about, how did that happen that that individual species has that cognitive profile, and what does that mean for their strategies and how they interact with their world? What are their weaknesses and strengths? What are the things they rely on? Thinking about them being smart or not doesn't even really make any sense anymore, because if you have a lot of empathy, well, maybe you're brilliant. Whereas if you have a lot of inhibitory control, maybe you're brilliant too, but in just a very different set of circumstances. Okay, so that's also cognition. Now, the last thing that's cognition is the idea that what we're talking about, all these different types of intelligence that we've observed, they're internal. They're hidden inside our minds. You can't observe. When I ask you, do you remember what you ate this morning for breakfast? And you think to yourself, I had cereal with some peaches on it. You didn't behave. There was nothing that I could watch to know that you had cereal with peaches on it. There was an internal mental process that occurred that allowed you to remember and represent and then articulate what it is that you had to eat. Minds happen inside the brain, and they're hidden in our heads. So you have to understand cognition to understand the process that's going on in the mind that then produces behavior. It's not enough to just study or think about behavior, because all behavior is produced by a mind, if we're talking about dogs and if we're talking about people. So this is a great classic example to illustrate how understanding the mind and the internal processes helps us think about cognition. So this is a famous illusion, the Miller illusion, where these two lines, can you guess which one of them is longer? So think about it for a second. And the big, funny, fun thing about this is it ends up, they're the same length. Now, I'm going to put this back up here, and it is impossible, even as somebody who teaches this, every time I look at this, the bottom line is obviously longer. And there's an illusion created. The way that we perceive the world, by having those two lines at the end of each line, it makes the bottom line look longer than the top line. You have no control of that. You can't stop it. And it's just beautiful evidence of how your mind is designed to process information in a certain way, and that by doing experiments like looking at illusions or playing games with dogs, we can get information about those internal processes, how they work, and sometimes how they don't work. So one more time, here we go. Which one's shorter? You can't do it. They're both the same length. All right, so thank you, Miller-Lyle illusion. Okay, so what is cognition? So To summarize, cognition is the mind flexibly solving problems. It allows for inferential reasoning, leading to flexible problem solving. There are many different types of intelligence, and we know this by taking a cognitive approach, and that these different types of intelligence, they vary independently. And finally, cognition really relies on a set of internal processes. You can't observe them directly. We can actually look at how animals solve problems, and we can ourselves make inferences about the internal processes going on in their mind. Just like we succumb to illusions showing that there's a perceptual system that I can't control consciously, there are things going on in animals, and there are internal processes that we can see by doing simple games and experiments, just like showing a personal illusion. Okay, so that is what cognition is.